This particular section, 7.2, is going to cover multiplying rational expressions and dividing rational expressions. Dividing rational expressions is just almost the exact same thing as multiplying, and you're going to recognize whenever we get to dividing rational expressions, you're going to recognize something about it because you're going to see it's very similar to just dividing fractions. But the basic thing to understand about multiplying rational expressions is that when you're done actually doing the multiplication, you need to simplify. Something to remember now and forever is that when you have an answer, you simplify it. If you don't simplify your final answer, then it is not done. So, let's talk about a basic rule for multiplying rational expressions. And this is going to look pretty familiar. Yeah, let's put a little more space there. So, if we have A over B times C over D, A over B times C over D. Well, remember whenever you multiply fractions in just regular arithmetic, you pretty much just multiply across. You multiply A times C, and that goes over B times D. It's the same thing here. So this whole thing is going to equal AC over BD. You just multiply across. It's the same exact thing with rational expressions. You have an expression on the top and you have an expression on the bottom, and then you just multiply across like that. That being said, you may be tempted, now that I've said that, you may be tempted to do a bunch of distribution to get it all factored out, not factored out, get that all distributed out, and as long as you possibly can. You actually want to factor the entire thing first, because that makes it much easier to simplify the expression. Let's go straight into an example, and you'll see what I mean. So let's say, for example, we have x plus 4 over x squared plus 5x. Say x plus 4 over x squared plus 5x times plus 4. I forgot the plus 4. And then times x squared plus 2x plus 1 over x plus 2. So now we have two rational expressions that we want to multiply together, and I think that you probably understand this well enough that I can move ahead without saying, because that's the basic rule of multiplying rational expressions. So what I mean by that is we're going to take this part and multiply it by this part. Don't forget to put parentheses around it whenever you do that. But before we even do that, I want to factor out every expression that I possibly can. This x plus 4, that's as factored out as it can go. But this x squared plus 2x plus 1, that is a perfect square. And I'm going to go ahead and skip ahead to what that perfect square is. It's just going to be x plus 1 quantity squared, because you have you add those two things together and you get, well, you multiply those two things out and you'll end up with the same thing over here. But this down here, this is going to be a binomial times a binomial. It's going to be x plus 4 times x plus 1. So let's go ahead and rewrite this entire thing as using that concept. So we have this entire thing is x plus 4 for the left one does not change, but for this denominator here, we can change this to x plus 4 times x plus 1. X plus 4 times x plus 1. All I did here was I factored this x squared plus 5x plus 4. And then for the right one, for the right the right rational expression. This top part is x plus 1 quantity squared. I just factored this out, and over x plus 2. So now we have something that we can we have something that's easier just to put together. Now I'm going to go ahead, if it's all the same to you, and rewrite this. Instead of writing it as a square, I'm going to rewrite it as just separately, long ways, I guess you might say, just because it'll make it just a little bit easier to cancel in the end. So based now on this, we just put those things together. I'm going to go ahead and put parentheses around the x plus 4 and x plus 2, because you have to understand that we're multiplying the entire thing, not just because, I mean, if you forget to put the parentheses in there, when you multiply the x plus 4, you'll end up just multiplying the 4 times this, but we want to multiply the entire thing. So on the next line, let's go ahead and put these things all together on a single rational expression. So we'll have x plus 4 times x plus 1 times x plus 1. I just took the three expressions here, x plus 4, x plus 1, x plus 1, all over x plus 4 times x plus 1 times x plus 2. So now that we have it in this form, we can see things that we can cancel out. Actually, we could technically see from this one, we could have canceled out here, but it's easiest to go ahead and put this all together and then cancel out everything that we can. So we can cancel out this x minus x plus 4 on the top with the x plus 4 on the bottom. Here's something that we couldn't have seen very easily before putting the two fractions together, and that's that we can cancel this x plus 1. So we can cancel the x plus 1 on the top and the x plus 1 on the bottom. Then we're left with just simply x plus 1 over x plus 2. And this is going to be our final answer. There's not really an easy way to check these specific types of problems, sadly enough, but except, of course, just to redo them and see if you get the same results. So that is going to be, see, when you multiply these two fractions together, these two rational expressions together, you end up with one pretty simple fraction, or rational expression. Let's go on to another example. Let's say x squared plus 2x over x squared plus 5x, and that times x plus 5 over x plus 2. Okay, so we want to factor out every piece that we possibly can. That's the first thing we want to do. Both of these are both as factored out as they possibly can. We can't multiply this out, factor this out any further. But this one, there's a common term in both the top and the bottom. So we can rewrite this as x times x plus 2 over x times x plus 5. So I just factored out an x from this top one and factored out an x from this bottom one, because there's an x common to both terms in each of these, in both the top and the bottom. And then this whole thing times, oops, I put the dot in the wrong place. Okay, this whole thing times x plus 5 times x over, x plus 2. And then we can multiply across. Technically speaking, when you're multiplying, we're just pretty much connecting the line like this, but whichever way you want to think about it. Just remember that if you do just connect the line like this, remember to put parentheses around the x plus 5 and the x plus 2. but I'm going to go ahead and write it separately. So this is the same thing. We're going to say this is equal to x times x plus 2 times x plus 5 over x times x plus 5 times x plus 2. Okay, so I just put these things all together on a single line. Okay, so what can we cancel? We can cancel this x. We can cancel this x plus 2. We can cancel this x plus 5, this x plus 5. So what's left? Is it 0? No. Whenever you're done canceling and there's nothing left, there is an understood 1. Remember that there's an understood 1 in front of all of this. So you have 1 over 1, which is equal to 1. So this whole thing is equal to 1. And 1 is our final answer. That's really important to understand. That when you cancel everything out, what's left is a 1. Okay, so that concludes that particular example. Let's go on to the next one. Let's say we have x squared plus 2x plus 1 over x squared plus 3x plus 2. Oops, I forgot to put x squared plus 2x plus 1 over x squared plus 3x plus 2, all times, because we're multiplying two fractions, or two rational expressions, remember, all times x plus 2 over x. I actually forgot to, whenever I made this problem, I forgot to multiply them out. So we'll go ahead and do the, well, you know, it won't be that hard for me to figure out how to multiply this out. X squared minus 2x minus 3. X squared minus 2x minus 3. Okay. Oh, I didn't need to put that in parentheses there. It doesn't hurt anything to put it in parentheses, but it's there's no reason to put it there. Okay, so the first thing we want to do is factor everything out that we possibly can. I'm going to write them out. Before I write them out over here, I'm going to write them out on top and on bottom just to make it a little bit easier. So this can be factored out as x plus 1 quantity squared, actually. X plus 1, but I'm going to write it as x plus 1 times x plus 1, just to make it a little bit easier to see. You don't need to if you can see it. I'm pretty sure I did it the other way in the previous video. So this part will be x plus 2 times x plus 1. So you can already kind of see that we can do a cancellation just in this one, but I'm going to wait till the very end. And this one is going to be x minus 3 times x plus 1. X plus 1. You can double check those individually, but at the moment I'm not going to take the time to do that. So we can say that this is equal to, we could put those things all together in a single step. I'm going to skip the step where I write these fractions out individually. I'm going to write this all out as a single fraction. So we have x plus 1 times x plus 1 times x plus 2. X plus 1 times x plus 1 times x plus 2. That's where I got that. Over x plus 2 times x plus 1 times x minus 3 times x plus 1. X minus 3 times x plus 1. Okay, so let me double check that and make sure I got it all right. X plus 1, yeah. Okay. So we figure out everything that we can cancel. This x plus 2 down here cancels with this x plus 2. This x plus 1 cancels with this x plus 1. Or that x plus 1, doesn't really matter. And this x plus 1 cancels with the last x plus 1. Okay, so what's the answer then? Is it x minus 3? No, it is not x minus 3. Maybe I shouldn't have paused that long to lead you into the temptation to believe that it is x minus 3. It's not x minus 3, because x minus 3 is still in the denominator. It doesn't matter that it cancels out everything in the numerator. Remember, what's left is an understood 1. So the x minus 3 is still in the denominator. So the answer then is going to be 1 over x minus 3. This is going to be, I forgot to put an equal sign there, so this is going to be the final answer, 1 over x minus 3. Remember that. I have a lot of people that sometimes will accidentally say that this is equal to x minus 3, and that is wrong. Alright, that concludes this particular video. I will see you in the second part, which is just almost the exact same thing, and whenever you see it, you will recognize that you're doing the same thing you do with fractions.